Okay, we back to the question. So we all agree that the highlighted component, which is the square root of x squared plus y squared plus 0 divided by L, it must be equal to 1 so that we can get the location where the flow field, the speed is equal to V0 or V0, meaning that this equation, you will get V equal to V0. We need to find the location. Okay, we continue with another slides. So this component must equal to 1. Is equal to 1. So when this equation equal to 1, you can rewrite the equation into this one become square root of x squared plus y squared plus 0 equal to L. Because this whole thing equals 1, you can move your L from the left to right. Your right hand side will become to L, become L. Okay, then you move the head. You move the head from left hand side to right hand side, the L will become square. You will have x squared plus y squared equal L squared. Again, it will tell you that you are achieving into a certain shape of the equation. This one is actually the equation of a circle. Right? On the screen here, it will give you the equation of a circle. X minus h squared plus y minus k squared minus r squared. So if you compare side by side, the equation of this one, now h is the x of the center of the circle, k is a y component of the circle, the center of the circle. Then the r is the radius of the circle. All right. Now, by comparing the equation of the circle, what is the value of h and k? All right, Shirley, are you able to answer? What is the value of h and k for the equation of circle?
Which one mean?
Huh? No, I'm asking
Which one do you mean?
Okay, if you look at the screen, yeah, I show you the equation of circle, right? X minus h squared plus y minus k squared equal to r squared, correct?
Yes.
Yeah. And then in the question that we need to solve, we arrive at x squared plus y squared equal to L squared. You compare this equation and this equation. My question is, what is the value of h and k, and where is the location of h and k if you compare side by side?
The value for h and k will be 0.
Will be 0. So when you have 0, where does the circle will be? It will be at where?
For h and k?
Yeah, means if you draw a circle, where is the center of the circle? It mean this equation. Where does the circle will be? Where the center of the circle will be? Just now you answered.
Will be on the origin.
Correct, on the origin. Raj and Dinesh, you able to follow?
Yes, sir.
Yes, sir.
Yeah, you understand why 0?
Yeah.
Yes, sir.
Okay. All right. Now I put side by side again the information. So from here, you know that your circle is at the center if you want to draw a circle. So you draw a draft of the circle. You draw x-axis and y-axis, and you know that the velocity field is in the circle form. The L is actually the radius of the circle. Okay, you draw an axis, x and y, and you only need to solve for the x more than 0, means you close the left-hand side domain. You don't need to consider the value on the left-hand side. You continue solving the question on the right-hand side. You draw the first circle. The first circle radius is L. Danish, you understand why the value of the circle, the radius of the circle is L? Dinesh? Do you understand? Here to here is L. Dinesh, are you there? Raj, are you there?
Yes, sir, I'm here, sir.
Okay, you understand the radius is L or not?
Sorry, sir, I don't understand.
Okay, you look at the screen, you compare side by side. We arrive at the equation x squared equal to y squared equal to L squared, correct?
Yes, sir.
Then you compare the equation of circle in the diagram here. You know that your h and k is 0 if you compare side by side. You want to get x squared, h must be 0, correct?
Yes.
Same with k also, you must get 0. Then h
Yes.
and k, what is there? Is the center of the circle, so it must be at the origin. So that's why we draw at the origin. Then what is the r? R is the radius. So
Yes.
if you compare this equation and this equation, r equal to L.
Oh, okay, sir. Okay, sir.
Can I get it?
I get it, sir.
Okay, Danish, you able to understand?
So I messaged him. He said he went to washroom.
Okay. All right. So I just continue. So Raj, you understand why there is a circle with a dashed line on the screen here?
Yes, sir.
Right. Now, if we increase the L, we will get the second circle with 2L. So here to here is 2L. Okay. We just develop based on our understanding. This is a general equation of the circle. We expand this one into this shape. So we draw a half circle because we only need to consider positive x. So we have x, L, and 2L. So far, any questions so far? Any question want to ask me? Able to follow?
No question, sir.
Okay, good. Okay, go a little bit faster now. And then you fill in all the places. For example, the x will be V0. Now, how do you know in this location you can write V0? So this coordinate, in this coordinate, okay, y, this one is L, this one is 2L. You should be able to understand if you just project the radius along. But how do we know that this location is V0? Because if you when you substitute the value of y equal to 0 in this equation, okay, in this equation, so for this point is y equals 0. This is your x, y. Your y value is L. So y value is L plus you need to find your x. So your x at the end, when you solve the question, you will get V0. Yeah, so this is V0, meaning your y equals 0. Your x here is, your x here is L also. So the value, the magnitude of this location is V0. So because your x is L, y is L, you simplify this equation, you'll get V0. Then you continue with the second one. This location is 2L. You substitute the location. X squared equal to 2L squared plus y equal to 0. You simplify this equation, you get 2V0. Okay. Next, we need to put in the direction. We have the flow field already, means a template for this equation. So we need to draw the flow direction. So recall trigonometry. You know that your vector, resultant vector V you can draw in this way, vector with the direction and magnitude. So if you can expand to x direction and y direction. The direction to along x you can write as u followed by y magnitude v. Okay, so this is the general recall of the velocity vector where you can expand according to the angle. So by looking at this diagram, trigonometry diagram, you can write the tangent equation, tangent theta equal to v divided by u. And recall, just now I already asked you what is u and v. Your u equal to minus v0 or v0 divided by L times x. V equal to v0 L times y. You substitute these two values inside trigonometry equation. Your tangent theta equal y divided by minus x. Any question so far? Raj or Dinesh?
No, sir.
No, huh?
No, sir.
Okay, let me check. Yong, are you there? Yong, you're there. Okay, I assume Yong is there. So we continue. Once you get the equation of the tangent theta, y equal to tangent theta equal to y minus x. So I rewrite the equation. Tangent theta equal to y divided by minus x. You should understand why certainly tan theta equal to u divided by v divided by u becoming this one. You must understand. Because you are substituting based on the scenario given in the question. Your u value and v value with the x and y just now, you substitute inside, you get tan theta minus y minus tan theta equal to y minus x. So we look at this axis, this axis. So along x-axis where your y equal to 0, your tan, when your y equal to 0, if you look at the equation that I highlight on the screen here, what happens if you have y equal to 0? Straight away, you know that your tan theta equals 0. There's only two scenarios when your tan theta can be 0. It's either theta equal to 0 or your theta equal to 180 degree. Yeah. So when the scenario when you get y equal to 0, there's only two, the value of the theta is 0 and 180. What happened to the x? Same scenario. Now you apply to x-axis, to y-axis, sorry. At the y-axis that I highlight with the dashed line here, y-axis is also x equals 0. All the x value along y-axis equal to x equal to 0. So what happens if your x equal to 0? You divide something with 0, you get infinity value. So tangent theta equal to infinity value, either is positive or negative. The tangent theta angle will be either 90 degree or 270 degree. This is the fundamental for trigonometry. Okay, so if you don't understand what is this one, why suddenly I can say tangent theta infinity theta equal to 90, 270, go back and ask Engineer Ma. Okay. Go back to our question again. So you have your u and v again. Along x-axis, where your y value is 0, so you look at your u and v component again. So along x-axis here, your y value equal to 0. So this one, your v will be 0 because y equals 0. All right, the equation, the velocity field, v equal to V0 divided by L minus xi plus yj. You substitute y equal to 0, means, or you can cancel. You only arrive at V equal to V0 divided by L minus xi. Okay, minus xi. Now this is a vector form, right? This is a vector form. When you have a negative I, what does it mean? It means, or when you have a positive I, it means positive I hat, it means you go along x-axis. If you have a negative I or negative value of the vector, it means it go in another direction. Okay, because we already defined all the direction to the right along x-axis is positive. So when you have a negative sign vector, it means that we can straight away draw the arrow of the magnitude here. Okay, the magnitude, draw the arrow is going to the origin. See, Shirley, you understand why the arrow is pointing this way and not another way?
Yes, sir.
Okay,
I
good.
understand.
Yeah. So same with the 2 VO here, because the y at this location also 0. This location also 0. So it apply the same. You'll get same direction, but the magnitude a little bit longer, so a little bit larger. You just substitute the coordinate into this equation. All right. We have solved for the x-axis. Now we solve for y-axis. So y-axis, your x coordinate along this axis is x equals 0. You write the equation again. Again, when you solve question, general equation is bottom. So V equal to V0 L, this is given by the question. You substitute x equals 0, or you can cancel. You arrive at V V0 divided by L positive yj. How do you draw on the scale here? When the positive is pointing up, this way 2L is a bit larger magnitude. If you substitute the y coordinate in this equation, right, you get a larger magnitude. What happened to this side? What happened to another side? Okay, another side, your y value in this location is minus L. So minus L here, minus L, J, you'll get going down direction, yeah? That's why you get going down direction. And same with minus 2L here. You'll get a larger arrow, but going down, not going up. All right, Raj and Dinesh, do you understand how to draw the arrow direction?
Yes, sir.
Okay, yeah. All right. The next one, more challenging one. What about the flow in this direction? For example, this location at 45 degrees from the axis. How do we draw the arrow? Huh? So ask yourself, again, what is the equation of the trigonometry? Pull this diagram out. Vector equal to the combination of small u and small v. And the angle was given by octang, or the 10 minus 1 on your calculator. Okay, or we call it octang. Octangs times the u divided by u, you get the angle. So at this location at 45, okay, at 45, we can draw a line in a straight line like that. Okay, at 45. And along this line, if you draw on the Cartesian plane, on the grid itself, this line, you can write y equal to x. So if you don't understand why we can write a line that is 45 degrees from the origin, y equal to x, go and flip your calculus textbook. And find out why we can write y equal to x for this line at 45 degrees. All right, a simple equation. They are right here. So you have a diagram. Vector v can expand to u and v again. Recall tan theta equal to v divided by u. And by substituting the u and v equation that you extract from the equation, you arrive at tan theta equal to y minus y divided by minus x. So along this line, the angle is minus 1. Along this line, the angle is 45 degrees. Okay. So tangent 45 is the one that we want to find. So if you along this line, because along this line y equal to x, so if you replace y as an x, you'll get minus 1. Okay, let's try to find out. Let x equal to y equal 1. So if both of them are 1, what happened to our velocity field? The general equation, v equal to v naught divided by L minus xi plus yj. If your x and y is 1, you replace as 1 any point in this line. You will arrive at this equation. You have two equations. One is v naught divided by L. Because your x is 1, you get minus I. So minus I, again, minus I, the arrow is pointing opposite of the x-axis direction, which is going to the origin, or going to the left. And another part of this equation is positive yj. It is this one. So v naught divided by L plus j, because our y value is 1. We get this arrow. So if you recall back what is vector, vector is a resultant force, is a combination of two vectors. So you need to always start with the origin, then focus on the endpoint. It becomes your resultant point. You get your v. The broad arrow that I draw on the screen here is the combination of this vector plus v vector, where it is equal to this this equation. So by having, if this location, let's say, is 1, right? Y and x equal to 1 at this location, the arrow will be pointing this direction. So pay attention to the screen here. One arrow will added to this location. So I add this arrow pointing this direction, going up like that. Okay, try to link what we discussed just now. Why the arrow is pointing like this direction? Why this arrow is behaved like this? Because we're substituting all the value x equal to 1 in this equation. All right. Then same apply for this location, where you have a larger magnitude at this location. Okay, I will take as a homework for today. So what happens if you have a negative 45 this way? Negative 45, you know that y equal to mx plus c is a linear line general equation. So if your m is positive, is going up, or you learn in your linear equation, right? When your m is positive, it means going up. When the line is going down like that, it is a negative value, where you can write this line y equal to minus x, like this one. Okay, you repeat the same concept like what you did for these two arrows here at this location. However, your y value is negative. x value is positive, you're able to get this arrow again. However, it's not pointing up, but it's pointing down. This one as is your homework, yeah? Same with this one. Go and study why we can draw like this. Okay.
Sir.
Yeah.
So can you explain again for the 45 degrees because I didn't get it just now.
Okay, I'll go back to this one. Okay. You understand all the straight arrow here, right, Shirley?
Yes, sir.
Okay. Now we look at 45. Right, pay attention, Dinesh and Raj. So at 45, right? So before you understanding what is 45, you recall the trigonometry equation where you can expand this diagram into tangent theta. So the angle of the vector can be arctan v divided by u. Let me erase. And then, so if you draw on the Cartesian plane at a 45 degree, you know that you have 45 here, 45 here, you'll get a straight line, y equal to x. All right, you'll get a straight line. If you're not sure, you just go and buy a grid paper. You draw y equal to x, means this line, y equal x means that 0, 0, 1, 1, 2, 2, 3, 3. You'll get a 45 degree line. Okay. Surely you understand, right? This one?
Yes, sir.
Okay. All right. So we go back to a trigonometry. Tangent theta equal to v divided by u. And when you substitute your value of your u and v, you'll get tangent theta equal to y divided by minus x. You understand up to this stage?
Yes.
Okay. Now along this line, the value, the equation is y equal to x. So if you look back this equation, you move your minus sign to the left hand side. All right. Or your y equal to x, you'll get tangent theta equal to minus 1. You agree with this one? You agree with this statement?
Yes, I agree.
Okay. Then you recall the boundary condition or the location of the node that we have. We know that along this line, let's say this point, along this point, you know that all the numbers will be the same for y and x. Okay. So this point, we will just use a one value, x equal to 1, y equal to 1. So this is the general field equation. V equal to V naught divided by L minus Xi plus Yj, correct? Then
Yes, sir.
Then you substitute the X value and Y value inside. You will get, what do you get? You'll get this times negative I hat plus J hat, correct? You have two equations here. You have two components here. One is the X component. Another one is Y component. Y component or Y vector. So this is X vector. The first one, this one times this one, you get negative I. How do you draw the vector? By looking at this equation. You can draw a line to the left. This vector represented by U0L minus I. You understand this one, Shirley? Why the arrow pointing to the left?
Yes, sir. Yes.
Then you continue with the y vector, which is going up. V naught divided by L plus J. Then we know that the combination of these two vectors will give you resultant force. Resultant force we measure from the end point to the start point to the end point, where you can draw a broad arrow like this. The combination of this equation, these two equations, will give you this broad arrow. That's why we get this direction. Yes, you understand?
Yes, sir.
Now you put the arrow back to this location. You do the same for this location. This is when your y and x equal to 2. You'll get the same, this one, only the magnitude is bigger. Then you can draw the larger arrow. Okay. Then.
Okay, sir. Now I get it, sir.
Then you do as your homework. You go and prove the direction at the minus 45. I just give you a hint. Minus 45, the line will be y equal to minus x, because it's going down. Y equal to ms plus c. If you don't understand, you just write y equal to ms plus t is a linear line. Recall how you find the gradient of a line, how do you find the intersection of the line, and so on. Then substitute again this location value, this location value. This one, your x is positive, y is negative, so it's no longer 1. This one, your y value is negative. X equal to, in this location, your x equal to 1, y coordinate is minus 1. You substitute into this equation, you'll get again 2 vector equation. Then you draw out the two vector, you'll get the resultant vector direction, like what I explained just now. Okay, it pointing down. Same with this one. Okay, another last question for today. If you look at the diagram that we just developed, what happened to the origin here? What do you think? Dinesh? Are you there, Dinesh?
Yes, sir.
Yeah, if you look at the screen here, and my question is quite simple. If you look, there's an equation. You understand? We have one equation from the question that I highlight on the screen here. Yeah. So what happened to the origin? What is the coordinate of origin and what is the value of your v? V equal to what? V equal to what? What is the coordinate for your x and y at origin? You understand my question, right, Dinesh?
Yes.
So what is the coordinate of origin?
Zero, right?
Coordinate. I'm asking for coordinate. 0 is only one number.
0, 0.
0, 0. So your x equals 0, y equals 0, correct? What happened if you substitute these 2 0 in the equation? What happened to your v vector?
0.
Correct. Now you can answer. Very good. So your vector equals to 0, what does it mean? It means that we have a stagnation point. It means that we have no flow at the origin. So sometimes this kind of explanation, also a 3 mark question, it will cost you 2 to 3 marks, something like that. It's a very straightforward a bonus mark, but it depends on whether you understand or not. What are the value mean? In this case, if your velocity is 0, means no movement, no velocity means no flow. No flow means stagnation point. Okay, Ross, you understand, yeah?
Yes, sir.
Okay, good. I think we have come to the last slides for today. Actually, this equation, it can be solved for the signboard flow above the signboard, a flow above signboard, or a traffic signboard, where you have a car coming in, the wind will hit the signboard, and the behavior of the velocity field of a flow from x direction in the 2D dimension will look something like what you draw on the screen here. Okay, so this is the 2D dimension where it will help you to visualize by using equation. You can visualize. You can give some graphic illustration of the flow motion. Okay, and you can see this one in the simulation ANSYS, ANSYS simulation results. But by using a hand calculation, you're able to draw and at least draft the flow motion behavior. Okay, so just to conclude today tutorial question, or what we try to teach you today, is that vector. Okay, recall what is vector. All right, recall what is trigonometry equation, what is tangent, sine, cos, mean. And then, yeah, today, just to recap, what is the equation of circle? Equation of circle is very popular in this module. So if can, you memorize or put this equation somewhere. And then what else? Yeah, basically it is. So yeah, vector form, how to find magnitude, and so on. So you must be familiar how to find the magnitude of the vector, v square, u square, v square, w square. All right, this one you learn in the vector. So if you're not sure what is vector, or you already forget what is vector, yeah, go and open up the mathematics book, look at vector chapter, just to recap how to calculate vector kind of things. You will see a lot of vector equation later on. Okay, with this we end our lecture for today. Let me stop recording.